Okay, so today we're going to talk about the ideal gas law, and this is one of the laws on your gas law reference chart. So it's this one right here, PV equals nRT, and then it gives you a value for R, which is always going to be 0.0821. And then it has a weird unit, liters times atmospheres divided by moles times Kelvin. So I'm going to show you how to use all of that and plug it in by doing 3 different examples. So make sure you have a calculator handy, and we will be doing some of those pressure conversions again. And you have all of that information right here on your worksheet. So this first example says if I have 8.00 moles of a gas at a pressure of 5.60 atmospheres and a volume of 12.0 liters, what is the temperature? So I want you to start by making a list. So we have P, V, N, R, and T. Okay, and so sometimes you're going to hear me call this law, instead of the ideal gas law, I'll call it PIVNERT, just because that's kind of what it looks like. So the pressure given to us is 5.60 atmospheres. The volume is 12.0 liters. N is moles, okay? So N stands for moles in PIVNERT, which is kind of dumb, but it's because little m means something else. So that's just what we have to use, okay? N is going to be 8.00 moles. Notice I'm including units with all of these things in my list. R is always the same. It's always going to be 0.0821 liter times atmospheres divided by moles times Kelvin. So the reason why the unit is so weird is so that in a minute when we plug it in, units will cancel, okay? So the unit does have a fraction in it. It's just really weird, but it's going to make things easier because R is always going to be the same. And then it says, what is the temperature? So that is my unknown. That's my question mark. So, grab some different colors. All right, so we know that it's going to be PV equals nRT. So what this is pressure times volume equals moles times R times T. R is the ideal gas constant, which is why it's always the same. Okay, so I'm going to plug in the numbers that I know, 5.60 atmospheres times my volume, 12.0 liters, equals my moles, 8.00 moles, times my R, 0.0821 liter atmospheres divided by moles times Kelvin. And then we're still going to multiply that by our unknown, which is T. Okay, so this is P, V, N, R, and T. PV equals nRT. So let me label that so you can see. This is P times V equals N, R, and T. Okay, so you can see that that's exactly what we just talked about. So we need T by itself. We're solving for the temperature, and the temperature will end up in Kelvin because that's what temperature always is in my class. So right now it's being multiplied. That's what the parentheses mean. So the opposite of multiply is to divide. So first I'm going to divide by 8.00 moles. Okay, and when I do 8.00 divided by 8.00, it's going to cancel on this side, but I have to do it on this side. So 8.00 moles is what I'm going to divide by over here. And then I'm still not alone with T, so I need to divide also by R. So I'm going to divide by 0.0821 liter atmospheres over mole Kelvin. Okay, I'm aware that it's a ridiculous unit, and yes, it does suck to write it over and over, but it is what it is. So when I divide by the same thing on top and bottom, it's going to cancel, but I have to do it over here. So we're going to divide by 0.0821 liter atmospheres divided by moles times Kelvin. Okay, so that is getting T by itself. So let's look at some units and see what cancels over here. So I have atmospheres on top, and then I have atmospheres here on the bottom. I have liters on top and then liters on the bottom. And then here on the bottom, since this R unit has a fraction, I have moles on top and moles on bottom underneath this fraction bar. So the only thing I'm left with here is K, which is a unit for temperature, Kelvin. Okay, so to solve this, you are going to multiply the two numbers on the top and divide the two numbers on the bottom. Okay, so let's do that. 5.60 times 12.0 divided by 8.00 divided by 0.0821. Okay, so this temperature is going to be in Kelvin because that's the unit that didn't cancel. So my T equals, and we're gonna round to 3 because everything given to me has 3 sig figs. R doesn't count, it never changes. Okay, so this has 3, this has 3, and this has 3. So I'm gonna round this to 102, so you can see it. And then the 3 does nothing to the 2, so it's 102 Kelvin. That's my answer for the first one. Okay, let's try another one. How many moles are in 6.9 liters, remember capital L just means liters, of a gas at STP? So I want to talk for just a second about STP. So it is on your worksheet, and what this stands for is standard temperature and pressure. Okay, so when it says STP, it's actually giving you 2 pieces of information. It's giving you 0 degrees Celsius and it's giving you 1 atmosphere. Okay, so you actually have more information there than you know. So I'm going to start with a list: P, V, N, R, and T. All right, and it's asking how many moles are in. So let's figure out first what we have. We have 6.91 L, and that's a volume. So 6.91 liters. My pressure looks like it's not given to me, but it is. When it says STP, that is my pressure. It's 1 atmosphere, so 1 ATM. My N, it says how many moles, that's my unknown. My R is always 0.0821 liter atmospheres divided by mole times Kelvin. And my temperature, remember STP, standard temperature and pressure, is 0 degrees Celsius. All right. So before I can plug this into the Pivnert or ideal gas law equation, I have to have my pressure in atmospheres, my volume in liters, and my temperature in Kelvin because of the units of R. So if my pressure is not atmospheres, my volume is not liters, and my temperature is not Kelvin, I have to make them be. So the only thing that's wrong is my temperature. I'm gonna have to add 273 to turn that into Kelvin. So 0 plus 273 is 273 Kelvin. Okay, so now that's taken care of. So now we can do PV equals nRT. So I'm just going to start with my P, 1 atmosphere, times my volume, 6.91 liters, equals N, which we don't know, times R, 0.0821 liter atmospheres divided by mole times Kelvin. And then we're still going to multiply that by the temperature, which is 273 Kelvin. And that is after we added the 273 because we were given a Celsius temperature when it says STP. All right, so we need N by itself this time. So it's going to be very similar to last time. N is being multiplied, so the opposite of that is divide. So first I'm going to divide by R, 0.0821 liter atmospheres divided by mole times Kelvin. So that's going to cancel there. So I'm going to divide on this side by 0.0821 liter atmospheres divided by mole Kelvin. And then I still need to also get rid of this 273 because it's also multiplying to N. So the opposite of multiply is divide. So I'm going to divide by 273 Kelvin. And that's going to cancel over there. And I got to do the same thing here. So let's look at our units now. So atmospheres on top, atmospheres on bottom, liters on top, liters on bottom, Kelvin on top, Kelvin on bottom because of this fraction. So this time I'm left with moles, which is my unit for N. Okay, so again, to solve, you're going to multiply the top numbers and divide the numbers on the bottom. So we're going to do 1 times 6.91 divided by 0.0821 divided by 273. Okay, so some of you are probably thinking, you left off the front 0, miss. It doesn't matter. It's a leading 0, so you can write it or not. It doesn't bother me. But you must have 0.0. That part does matter. Okay, so I got a pretty small number, but that's okay because it's moles. So N equals, let's look at our sig figs. The only number I was given at all in my problem, because STP doesn't count, the only number I was given is 3 sig figs here. So we're going to round this to 3. So this is going to be 0.308 because the 2 makes the 8 stay the same. So 0.308, and the unit is moles. Okay, so that's how you do that one. So let's do one more. And this time I want to show you what to do when your pressure is not in the right unit. So it says, what is the volume of 2.15 moles of gas if the pressure is 741 mmHg and the temperature is 23.0 degrees Celsius? So I'm going to start with my list: P, V, N, R, and T. All right, so my pressure is 741 mmHg. My volume is unknown, didn't give me one. My N, 2.15 moles. My R is always the same, 0.0821 liter atmospheres divided by mole times Kelvin. And then my temperature is 23.0 degrees Celsius. Okay, so if you look at your units of R, your pressure must be in atmospheres and your temperature must be in Kelvin. So first, let's go ahead and add 273 to turn our temperature into Kelvin. So 23 plus 273 equals 296 Kelvin. All right, now my pressure is wrong. It has to be in atmospheres. So this is where we're going to do our little one-step conversion. Again, you have this on Canvas. So if this is mmHg, this is going to be mmHg, and then we're going to go to atmospheres on top. Standard for, and you have this on your gas law reference chart as well. Here's all the standard pressures. Standard for atmospheres is 1, and standard for mmHg is 760. So we're going to multiply the top and divide the bottom to get our pressure in atmospheres. So 741 times 1 divided by 760. All right, so 0.975. And so that's going to be our starting pressure in atmospheres now. Okay, so now I can plug in my stuff. So I have PV equals nRT. Remember, when the variables are next to each other like this, it just means multiply. So P times V equals N times R times T. All right, so I'm going to plug in the things that I know. So I know 0.975 atmospheres times my volume, which I don't know, equals my N, 2.15 moles, times my R, 0.0821 liter atmospheres divided by mole times Kelvin, and then times my temperature in Kelvin, which is 296 Kelvin. Okay, temperature must be in Kelvin, pressure must be in atmospheres because of the units of R. Okay, so this one is really nice. You're gonna really like when you're solving for volume because volume is just being multiplied by one number. And the opposite of multiply is divide. So all we have to do is divide by 0.975 atmospheres. So it's not quite as intense. Okay, but if I do it on this side, I have to do it on this side. So we're gonna divide all of these by 0.975 atmospheres. All right, so now let's talk about units that cancel. So I have moles on bottom, moles on top because of this fraction. I have atmospheres on top, atmospheres on bottom of this big one. I have Kelvin on top and Kelvin on bottom of this little one, and I'm left with L, which is liters, which is a unit for volume. Okay, so to solve, you're going to multiply these numbers on top and divide the number on bottom. Okay, so we're gonna do, so you can see, let's get this up, 2.15 times 0.0821 times 296 divided by 0.975. All right, so that's my volume, and that's gonna be in liters because that's the unit that didn't cancel. So if we come over here to all of my givens in the problem, everything had 3 significant figures again. So I'm gonna round this to 3. So the 8 actually makes this 5 go up. So it's gonna be 53.6 liters. So my volume equals 53.6 liters. Okay, so the tricky thing about the ideal gas law is not the numbers. The tricky thing, I think, is knowing which variable you're solving for and what to do. Always you're going to be dividing. At least one of them will be divided every single time because the only information you're going to be given is R and a couple of the other ones, okay? So you will always be dividing something. It may be one number, it may be 3 numbers, it may be 2 numbers, okay? But you will always be dividing something. Make sure you're showing your work with your list out to the side and then plugging in the numbers over here. Your answer goes in a box with units. Email me if you have any questions.